Hello, my name is Juan del Valle, and today I'm gonna present an overview of an article called Performance Improvements of Evolutionary Algorithms in Perl 6. This article was made by Juan Julián Merelo Huelva from Universidad de Granada and José Mario García Valle from Instituto Tecnológico de Tijuana. You can find the article in the link shown in the PowerPoint or at the ACM Digital Library. So, what are the keywords you must know? First, evolutionary algorithms. Evolutionary algorithms in AI is a subset of evolutionary computation, a generic population-based meta-heuristic optimization algorithm. Perl is a family to high-level general-purpose interpreted dynamic programming language, and the latest version, Perl 6, is a new concurrent dynamic and multi-paradigm language built from the ground up. Then there's also benchmarking, which is the process when you measure something against other competitors to discover how to improve your performance. And there's also concurrency, is the ability of different parts and units of a program, algorithm, or problem to be executed out of order or in partial order without affecting the final outcome. So what are the research questions? First, what is the historical and current performance on Perl 6 compared to other interpreted language? What kind of scaling and performance we can expect from it? So why is this important? Performance has always been a concern in the scientific community. Usually you want the fastest language. While this is important, other aspects such as available library, readability, and so on, new languages deserve to be tested just because compiled languages usually have better implementation, so does interpreted languages has better prototyping. That's not always the case, and performance is not a static thing, because in the nowadays performance is the main focus on newer languages. What were the methods or the main functions? First, there was the one mass function, the main one, which is a simple optimization problem such as finding the maximum sum of multiple strings which has multiple numbers. Then there's bit-flip mutation, which is a common mutation operator for evolutionary algorithms applied to optimize function over binary strings. Then there's also crossover, which is a genetic operator used to combine two parents to generate a new offspring, such as two array lists to combine to one. And there's Royo-Row function, which I don't know very well, but it was used to compare Perl 5 to Perl 6. So, what were the results? As shown in Figure 1, which is a plot of time needed to perform 100K one mass evaluation in several versions of Perl 6. We can have the string have a length or increasing factor of 2 from 16 to 215, and please note that all these graphs, the S and the Y, both have logarithmic scaling. Figure 2 is comparing the result with the other interpreted languages, and as you can see, Perl 6 is at the middle of all the interpreted languages. Then Figure 3 is the result of the time needed to do the bit-flip mutation, and here it is crossover, and finally is Royo-Row comparing it with Perl 5 and Perl 6, and as you can see, Perl 5 is performing better than Perl 6. So what were the results? And as we can see, Perl 6 achieves level of speed comparable to those scripting languages, which means that it could be faster than some compiled languages. Perl 6 also offer functional methods that allow chaining operators such as .raise, .sum, which won't discuss that much in detail here, but you can check out the article. And Proset is still slower than its sister Perl, and you can find, if you want to know more about Proset, you can check the official doc, or if you want more in detail, you can check the article shown previously. And that's it. Thank you for watching. Please let me know if you have any doubts, and see ya.